So my name is Matt Dimich, and talk about Spring today. Just a tiny bit about what I'll go through. This is some of the areas I want to hit on. It's kind of an intro to why I picked this topic. Been doing a lot of interviewing because we're hiring, and just throughout the years, it seemed like a lot of people use Spring for the basic stuff, dependency injection, that kind of stuff. I mean, it's easier to test your application when you're using Spring, but when you start diving into a lot of other really cool things, there was less widespread knowledge about it. So I thought I'd go through a lot of things that I actually went around to several different teams and gathered some of everybody's kind of best tips and classes to use in Spring and that kind of thing. So that's what we'll go through today. We'll do some PowerPoints and lots of code. So about me, I've been working at Thomson for about 7 years. Most of it in the Java web services space. Had a little bit of everything, like Becky said. If you pick a technology, it's at Thomson. I started and I didn't know the mainframe in college at all, but I was the owner of a subsystem on the mainframe right in PL1 for a while, and owned C++ app for a little bit, and then finally into web services more. We had a huge, heavy SOAP web service application that I worked on for a while, and now we're in lighter, more open source, RESTful world, and that's kind of what the basis of my presentation will be on today. So again, basic Spring. What I'm calling basic Spring for this is dependency injection, which makes your application easy to unit test, and then beyond that is what I am talking about, is beyond. So what else is beyond basic Spring? Well, Spring is very modular, right? There's several different libraries to pull in. There's an amazing amount on this cluttered slide of Spring projects in every little area that you can think of. What I'm going to focus on primarily here is within just the Spring framework project. There's a little bit outside of that, but most of the Spring framework and all of even it's componentized underneath Spring framework as well. You don't need to pull in everything just to use it. So one thing that I've noticed, I went to No Fluff Just Stuff. If you've ever been there, it's a really great Java conference. Gone to a bunch of Spring talks with them, and everybody's talking about Java configuration. If you've used Spring before, you know that it can be XML heavy, at least in former versions, and everybody's talking about this. So I'm not going to go into a lot of detail on all of the various Java configurations you can do, but everything in the examples tonight will be using Java configuration, so you get an idea of why it's a little nicer than using XML. So let's dive into just a brief summary of that. So Java configuration all starts with the at configuration annotation. You have a class. Instead of an XML file, you have a class that has this configuration annotation on it. On a side note, we'll get into this a little bit deeper later, but the at configuration is also marked with at component, which means it's just a Spring bean. As soon as you put that on there, that class becomes a Spring bean and is loaded with your application context. Some of the other cool things you can do, now you can do component scans using Java configuration. I know there was a time in our application where we do a component scan in XML, and then everything else was in Java configuration. And now, slowly but surely, you can do everything in Java configuration, at least almost. And then another classic example of things that got lost in XML land would be the annotation-driven with Spring MVC, which again we'll go into more detail here. You have to mark your XML with annotation-driven, so you can use things like request mapping and make a RESTful web interface very easily. So now there's a new annotation for that called Enable Web MVC, which we'll see in a little bit. Let's hop out here real quick. So, yeah. Everything I'm going to do tonight will be using the latest, Spring 3.2. And so this is just a link out. If you go afterwards and find the presentation, you can get a link out to the documentation. There we go. So we'll see an example of Java config real soon. So then the other thing we need to know before we dive into some of the details is Spring MVC. And so here are some of the reasons to use Spring MVC. Features. MVC, just like with any MVC pattern, clear separation of roles, powerful and straightforward configuration. Spring's website has a whole list, as you can see, which I won't read through all of those for you. There's a lot of reasons to use it, but what we find it, if you don't get anything out of the presentation tonight, Spring MVC helps us write RESTful web services without the clutter of all the infrastructure stuff, right? Your business logic is foremost and the most important. And so it gets everything else out of the way, and that's what we'll see in the code tonight. So when you dive into how Spring MVC works, it's based largely on something called the dispatcher servlet. The dispatcher servlet follows a front controller pattern, and so requests come in, everything goes through. You find one servlet, everything goes through the dispatcher servlet, and then it gets dispatched from there, hence the name, into all the controller methods and the actual HTTP endpoints that you create. That takes care of all of your business logic, etc., throughout whatever stack you may have. And then ultimately, the last thing dispatcher servlet does is bring your view together and return a response. So very high level. All right, so now let's hop into some code. I've got two projects. A warning, I oversimplified the application, but I did not oversimplify the Spring components of it, right? So I didn't want to get this, you say beyond basic Spring, I didn't want to have this so difficult application to follow that we didn't get anything out of it. So it's really simple, I'll warn you that now. So it's a to-do application. All it does is it's a web service, and it just takes, you can create tasks and get all the tasks and get the tasks by user, and it's I think there's a total of about 10 endpoints we'll go through. But the first thing is stereotypes. So I'm going to hop in. I'm going to start at the controller layer, and we'll just kind of walk through it from there. So I have a task controller. So this is the entry point, and when I say stereotypes, I mean this @controller annotation. Now, the basic one is @component, and when you mark your class as a component, Spring, it's the same thing as wiring it into your XML file. Spring then knows, as long as you have a component scan that's looking for those annotations, Spring knows that it should suck it into the application context so that when your application starts up, Spring knows how to inject that instance of that class. And so when I do controller, it's a specialized component, meaning from now, and I'll demonstrate more in the code, some of the powerful things you can do when you know that this is a controller with its annotation. But that's one of the basic things to understand. So let's go over the first endpoint, and we'll get an idea of some of the annotations that Spring MVC gives us that make it really easy. The first one is request mapping. So if I take this out, and I will here, server. So this endpoint, just very basically, I have some data that's bootstrapped, and this very basically I'll hit this URL mapping, and it'll just return a list of task objects. Now, there's a lot of extra stuff going on, but I've got a Fiddler session up. If you're not familiar with Fiddler, just a HTTP request tool. It's very handy. So I'll look for the version 1 of the tasks endpoint, and it's a GET request, and I'll execute that. Is that what actually? Yeah. And we see that I have a whole JSON response here with all of the tasks that are in the system. So there's 9 tasks in the system. 5 of them are mine, and 4 of them are Sam's. So when I executed that, it knew to go to this method and execute this. So now one of the interesting things and best practices is request mapping by default you don't actually need to tell it which HTTP method you're going to use. And if I do that, I can come back and no matter what I do, I can, yeah, that's why I said almost. It'll map to the same thing. So that's why it's advisable to always explicitly say which HTTP method you're looking for. The other thing going on here is response body. Now, the alternative maybe is best. Maybe that's best described by showing the alternative. And this is at least how our code used to look. So this is the equivalent endpoint, only we're using a model map and a JSP to render the JSON back in the web response. There's several reasons why this gets hairy, right? This is where technology gets in the way of your business logic. You've got an HTTP servlet response, which I'm sure many of us have tried to mock and test, and that is a great, loads of fun. You've got the model map, which then you get to, which isn't as hard, but still, you get to dummy it up with data. And then you get a JSP, which is really easy to test, right? I know we have an elaborate set of endpoint sets just to test the JSP, and the amount of time you waste in something like that is spectacular in a bad way. So that's the alternative that we're comparing. But when we come here, it's one annotation. I return a list of objects, and boom, your JSON's returned. So that's what I'm talking about. The business logic is right there. It simplifies. Next one, say we create a task. We've got a few things going on here. One, I said request method post. And then a new thing that we actually are just starting to consume now, it's called the consumes attribute. And so that allows us to say, this endpoint will only take JSON in, or XML, or whatever MIME type you want to use. I've picked JSON because we do a lot with JSON. So I'll flip back over to Fiddler, and if I pull a post request to version 1 of the task endpoint, now it's the same URI. Here's where we go RESTful, right? Only at the post, meaning we're going to create a resource. And here's my resource I'm going to create. So I've got a JSON payload, and I'm telling, hey, I'm telling you, I'm sending content type application JSON. So when I do that, we get a 201 back because it was created. So I'll hop back real quick to my get endpoint, and I picked the wrong one. There we go. And I think I said go to the meeting is my new one, I believe. And so now it comes back in our list, and we have 10. So looking back at the endpoint, then if I want to test that out, here's what consumes does for it. Just in case. I know I changed something in there. So if I try and say I'm going to create a new task, but I'm going to use application text, which is not right, Spring takes care of the appropriate HTTP response for us. So 415 is, what is that one again? Unsupported media type. So we're saying in our endpoint definition, hey, we only want JSON, that's all we're going to accept on this endpoint. All the rest of the details just kind of work themselves up. That's cool. The other thing of note is the request body annotation. And this is the, there's another alternative I'll show you for this one, but all I want to do is take whatever JSON payload is in the request body and shove it into an object, right? Your basic web service serialization. Well, what we did before, go back to my previous, to get the same thing done, And you can simplify this by pulling out some of the Jackson code into a helper library, but it still doesn't get away from the fact that in your controller method, I have to take the request input stream, give it to a object mapper, because we use Jackson, there's other ways to do it, to get my task class, and then I can do my tiny little bit of business logic right down there. And instantly 95% of the method is not the business logic. So that's kind of the drastic difference in what we've seen with this technology. Oh, by the way, if you guys have any questions, feel free to ask at the time I'm talking about it, because that's when it's, I should have said that in the beginning, but that's all right. Super. What's that? Oh, how do they know that I only wanted JSON? That's the consumes attribute. So when I put a consumes on there, that maps to content type, the content type header. And then the next thing we'll talk about is that there's a mapping for the accept header too. So it's what I'm giving you and what I'm getting back is what we get to configure now through an attribute on the endpoint. I'm sure I would be surprised if you could, yeah, it's a string array, so you can give it a whole list of possible content types. If you take out the consumes, it'll be the same as accept anything. Sure.
Yeah, the first method you showed us had a response body, but it didn't have a type on there to return JSON. How did it know to return JSON?
So that was this one? Yeah. Yeah, no, yeah, if Jackson's on the class path, it just defaults to it. Yep. I'm sure I would pick one, but I don't know for sure. Right? Yeah, that's a good question, because that's why I say make this explicit, and that's why I like consumes and then now produces, because it's explicit. And if there's anything that I've learned is that when it's kind of ambiguous and you don't know for sure, you get undefined behavior. And I think that's where this gets really handy. It's all laid out right in front. Good questions. Next one is produces. So this one's kind of cool. So if I want to create another task, I'm sorry. I'm going to jump down to this one. Actually, getting a individual task is a little bit more. Is a better example. So now that I've got a list someplace, all right, so I'm going to grab one of these IDs and then go to V1 tasks and then the task ID. So it's a get, which means I don't want that. V1 tasks and then my task ID without the task ID equals. Content type, JSON, that's for the consumes attribute, and then accept would be for the produces attribute. So when I do this, you get a 404 because you type it in wrong. V1 tasks, SMB, get. Oh, I know this one works. 404. There's got to be something that goes wrong. It can't go flawless. That would be a problem. Yeah, there are. Get rid of our bad example there. Get the get. Most to V1 tasks. That is strange. I know I'm doing something wrong because this. Well, if you believe me, we'll go back to the list endpoint. That works. See if we can get a 200 back. All right. So we get JSON back on this one. So I'll go back to the V1 and we'll just modify that. So here, if I say replacement. Oh, not that one. In my request mapping, I want to say that this produces JSON and only JSON. Nice part about a small application is it takes 3 seconds to reboot or to restart. And then I'll come back and hit this one again. It will, let's say I'm being malicious, not really malicious, but I want XML back. It's not going to tell you. This is what happens when you switch it up last minute. Produces application. Oh, sure. That's because that, so good lesson, content type is for consumes. Except, if you don't have the accept header, it's accept star, which means accept everything. And so, therefore, it gave it back to me. But here, if I type in application text, V1. I went back and my other, I don't know why my other endpoint wasn't working. Maybe it was supposed to be V2, but we'll get there. So I went back up to this initial endpoint just to get a list of tasks and added it produces just JSON. And then when I execute it, it out of Spring again knows that, hey, those don't match, so I'm going to give you that this is not acceptable content type. So again, another example of it just does the right thing for you with the right status codes. Let's see if I hit all of these. Yeah. Path variable is what I was trying to get at with this endpoint. We'll give her one more time and see if I've done something right now. JSON to do tasks. I never fixed it. View only tasks. Get application JSON. Okay, I don't know. My demo is not going to behave today. So the path variable is how you match up something in the path to just a variable in your controller method. So when you're trying to unit test your controllers and you've got information coming from your URI, it's really easy because the signature of your method is just a string with an ID, and there's no request response to mark. That's the point. Great question. As long as you use the same name, you're good to go. Say that one more time.
If you don't compile with debug turned on, then the variable names are locked and it can't
Sure.
Spring has a way around that.
Thank you.
One more question.
Yeah.
If you had a version,
What if I had a version?
if you had a version of the web on one of your other.
Oh, yeah. This guy? This one?
Yeah.
Yeah. That I will get into next. No, that's all right. I knew it was going to happen because I put it on the earlier endpoints. I should have put it later, but no, I will absolutely hit that. Yes, I got those. So the next thing, not next. Wait, one more thing. Interceptors. Handler method argument resolver. This is something that's been renamed in the recent version of Spring. It's messed me up a little bit because we're still on a couple versions back. It used to be called Web Argument Resolver. Now it's called Handler Argument Resolver. And this is cool. Another way to clean up boilerplate code, focus on business logic. It makes testing even easier, and you'll see why. And there's a couple of applications that I've seen and that we use right now at Johnson. One of them is, and the most common, is to extract common HTTP headers. So we've got a web service environment that's bound by a session, and we pass a lot of information via headers. And this way we don't have to, again, get the request object, pull each header individually out of it for every controller method that you want to go. So let's take a look at that. So what I did on this one, I pretended, and you can see it in my Fiddler session, that on every request we get, we want to keep track of who's calling. So assume they log in to a web application, and as part of that session, you fire up and you have a list of headers that you want to pass around just to make sure people are who they are, who they say they are. So we pass around name and we pass around user ID. So when we do that, I can come in and I just made up an object called request context. And request context has just those two fields in them for demo's sake. And notice I didn't do anything special. I just declared that, hey, this method takes the request context. It's got a request mapping of V2 tasks. And then just for another comparison's sake, I used the request header annotation to pull out directly the name header. So here I'm just going to spit out to the logs if I use the request context, and then here's if I just use the request header name. So V2 tasks. Now when I execute this, I get the list of tasks, and then I'll go back to my console output. And here are the two lines that were put out. So it was requested by Matt-123, and then this comes from the header. So let's take a look at that one more time. So this came, and I got the name from that object, and then also just to check, double check, I got it there. Now, the alternative, again, is the request object and then accessing the header right from there. That's a good question, and it's not just any bean. There is some magic, or some reason to the magic, I guess. So to implement a handler argument resolver, there's two things you can do. One, yes, there's one way to do this one. You implement the handler method argument resolver interface, and that interface has two methods. One is supports parameter, and one is resolve argument. So you first implement supports parameter to type check and say, okay, if it comes through and sees that there's a request context, make sure that I support filling a request context. And if I do, this method returns true. If this returns true, then Spring knows to call the resolve argument method. And from here, I can do really whatever I have access to. I can grab headers. The other example that I saw on the web, I'm just trying to find other ways people use this, is the pre-fill entity. So you wouldn't have one in a database session by any means, but you could if an ID, for example, was coming in on the request, you could go get the rest of that entity, and all that would be behind the scenes. So in your controller, you don't have to explicitly do it if you don't want to. Again, for us, it suited itself better as a grab all this meta information that I don't want to go rip out in every endpoint. This way. Yeah. What's that? Yes. I believe it's a wrapper for the HTTP servlet request. Yeah.
So, argument resolver, is that running against every endpoint that gets it and trying to create a contact?
It calls supports parameter for everything. If you have a request, only if you have a request context in that method signature would it actually call the resolve argument. But it is running against every request. That's true.
So are there ways to get it in at all? I'm just thinking like start having, a couple dozen argument resolvers or something.
Yeah.
Whatever.
Well, I don't know. I haven't seen any mapping capabilities here. There are with interceptors that we'll talk about next. Do you know if you can actually map or filter them down on give a URI pattern or something?
Well, I believe that what Spring will do, because this is information available at application context setup time, so when it does its magic to map these, it doesn't check with every call, but it checks every controller method at setup time. So it's not doing this every time. So once you load up, you're not really taking it in.
So, formal introduction. This is Ryan, and he works on the team very close to me, and is written largely some of the stuff that we do at Thompson. So, I brought backup. That's what I'm saying. All right. So that's a handler argument resolver. I think that's all I had to show on. Yeah. Okay. Next one I wanted to run through was interceptors. Interceptors are pretty cool. We get a lot of use out of those. Now, interceptors are conceptually like a servlet filter, only they run in the Spring world, not out in the web server context. And so you'd say, well, why use an interceptor when I know how to do a web filter, and I'm comfortable with that. Well, you can auto-wire Spring beans into it. We'll see that. Here's where you can use a more advanced mapping style. So I can say, if the URI pattern's like this, then I want to run these interceptors. If not, then don't. I can choose. You have the target handler object available, essentially the controller and controller method that is going to actually do the work for this endpoint. And then it's I'm not saying you should do this, but you can use AOP around the interceptors if you need to as well. This one has two options. Spring gives you an interface called Handler Interceptor, and then they give you an adapter called Handler Interceptor Adapter, which is a convenience abstract or base implementation. Sorry, which means you can pick and choose which actual method you want to implement. So I'll show you what I mean by that. Resolver. All right, so the very first one, and here's, I'll look at the Interceptor Adapter. There's three methods, and I'm going to ignore, there's one called after concurrent handling started. There's some special, this particular base class extends async handler interceptor, which allows you to deal with some of the async servlet 3 cool stuff coming out. I'm not going to go over that in detail. I think that's a whole talk in itself. But so I'll focus on the base methods, which is pre-handle, post-handle, and after completion. So pre-handle runs before the actual controller method gets called. Post-handle gets called after the controller method has executed. And then after completion is after everything is done, the response has been essentially written. There's a more robust, if you look up the code, if you follow the trail of implementations, the Java doc on those methods do a very good job of explaining all of the details around when they're executed. The other cool thing is, is the order, I guess. They are symmetric. So if you have two, I'll show you, I think the easiest way is to show you. All right, so now I'm finally getting to your question. So what is this this deprecated endpoint thing? Well, this is one of the things that all of the Spring stuff allows us to do, and half of this talk, and largely the second half, will go into some of the pains you get in a bigger team. So I have had a team of 16 developers, 16 people cranking out code. And so when you get into to that many people, it's hard to, you know, wrangle them in if somebody goes off and tries to, you know, do it their own way or that kind of stuff. It becomes interesting. And so some of this stuff is around how do you guide yourself and guide a team into code quality standards. You know, there's a million ways to do everything, and so sometimes you just got to pick one and go with it. And if everybody's consistent, it's the best thing for the team. Things like that. That's why we use this kind of stuff. So one of them that we've used to communicate between teams, we've got lots and lots of teams working in the same web application. That web application is made up of a lot of different web services that only talk to each other via REST. How do we say, hey, this endpoint's old, it's deprecated, you got to move on to the next version? And so one thing we did to solve that problem was create a homegrown deprecated endpoint annotation. And so you throw that on there, you say, hey, this expires on this date or with this release, however you want to do it. And the replacement, and here there is no replacement, so good luck. So let's go back to my V1 example, and I'll show you how it automatically works. To do V1 tasks, execute, of course, that's the next example. All right. 200. Now, I'm going to actually look at the response headers, so I just look at it in raw view, which seems to be the best. Notice deprecated equals true. So that automatically comes back on every endpoint that has that deprecated endpoint mark on it, which means we can build a whole bunch of tools that inspect those headers and flag, send emails, whatever, give a display of how many times the deprecated endpoint's been hit. But in other words, we can automatically know that, hey, we've got some work to do. We've got to go upgrade this endpoint. So that after you get this kind of information in there, you can do anything with it, right, as far as operationalizing it with your team. If you're working in a larger environment. If you're working in a smaller spot where you're in control of all the web assets, probably, you know, wouldn't spend the time doing it. But it's pretty handy. So the magic behind that then is in interceptors. So I have a deprecated endpoint interceptor. And what I did here is extended the adapter so that I could only implement the methods I was interested in. So in the pre-handle, here's some of the heavier Spring magic. In the pre-handle, I check to see if it's deprecated, passing in the request and the handler, or ultimately the controller and method that will handle the request. And if that is deprecated, then I add the header. And here's where you could also do anything. You could send an email alert. You could, you know, pick your poison. I'm not even kidding, there is a comment in our code from this point on that says it might be detrimental to your health if you read this code. So I'm not going to walk through this line by line. But some of the cool stuff is you can get the name at a high level, you can get the name of the handler, you can get the class that this is ultimately going to resolve to, and you can check it out so you get the method, and you can find all the parameters or all the annotations in this case. So you just check to see if this deprecated endpoint annotation exists. Here's where once we've found the controller method, which is the hardest part, you find if this deprecated endpoint class exists on that method, and if it does, you know you have yourself a deprecated endpoint. Does that make sense? What did I want to do? I wanted to, not yet. Here. Also, I want to take a look at the logs. The second example I have for an interceptor is a caching interceptor. Is anybody, are you guys familiar with e-tags? Okay, so the sunglasses looks good. So e-tags being a web cache, so once I say I've got a list of tasks, that list of tasks is not going to change unless I add another task. And so from the time that I get the last list of tasks, you can return an e-tag header, which is a GUID that represents that resource. And next time I go ask for it, I pass that e-tag back in and I say, hey, I'm getting the same thing. Has it changed? And if it doesn't change, that's where you get the HTTP response code 304, not modified. So here's where I can show you if I come in and I get the tasks again. So I got them right here. If I get them again, I get a 304 because I'm in a very simple cache that I'll show you. But I know that that endpoint has already been hit and that nothing has changed. Now, if somebody comes in and creates a new task, I'll do what's called invalidating the cache, and I'll wipe it out so that the next time you come and get it, you get all of the latest data. So something like this means that I can have a cache interceptor that does all this for me with a tiny bit of configuration, and I'm not in every single endpoint saying, okay, does this exist in the cache first, and then moving on to the business line. So I'll take a quick peek behind the scenes. And the reason I pulled this up is the order of the interceptor. So I have 2 interceptors running that get hit on this request. And you can see that the deprecated endpoint interceptor pre-handle goes first, then the cache interceptor pre-handle, then the cache interceptor post-handle, then the deprecated endpoint interceptor post-handle. So that's what I meant by symmetric. It's like, I guess that illustrates it. I don't know how to better describe it. Oh yeah, and then I can continue going down this. For some reason, I thought it was repeating. After that, then we get the caching interceptor after completion and the deprecated endpoint after completion. Then it starts over again. Very good question. For this application that is trivial, thank you, that reminded me I didn't show you this other thing either. Here's back to Java Spring configuration. If you have done this in XML, you know that you do annotation driven, and then there's an MVC namespace. This is the replacement for the MVC namespace. And so I throw enable web MVC as an annotation on my Java Spring config class. And then how I add in Interceptor is I extend web MVC configure adapter, and then I can override this add interceptor method and add. And right now it followed this order for custom interceptors. Now there's Spring interceptors that also get run, and I don't touch those. So those run first, and then these run. And then I can't remember, Ryan, if you remember, but is it the ordered interface for this? Or is that for handler exception?
Exception. Where you're explicitly finding the order.
Yeah, it's just the configuration, right? Yeah. Right. Super question?
Yeah.
It might be 3.1. I think it might be 3.1. What I failed to show you earlier, when I did the web argument resolver, or the handler argument resolver, the request context, I had to tell Spring to register it with Spring to, hey, I implemented one of these. And how I did that was this add argument resolvers method, and I just made a new request context argument resolver and added it to the list. All right. I'll quickly go over the caching interceptor. So in this case, all I did was in the pre-handle when they're coming in, I checked to see if the resource is cached, and if it is, the contract to the pre-handle method says Spring will assume that the pre-handle will do everything it needs to do with the response. If it says to not continue on, essentially. So in the interceptor pre-handle, I can say, yes, continue on down and execute the controller method, or don't. And if not, then I should tweak the response if I need to. And so what I did here was, here's where I added the response status. And then after completion, if it actually, post-handle, if it actually gets to this spot, I actually add, and here my simplistic cache is revealed. I just get the URI and the method. And if it's been hit before, then I cache it. again, for demo. Is there a round annotation to that one more time? Mm-hmm. Well, yeah, you could have an aspect, right, that wrapped controller methods. That would do something very similar. I'm trying to think some of the, yeah. I don't have a good example of how you could do the same thing with aspects, but likely you could do a very similar thing. Cool. Another, just a side note on eTag, if you're interested, I was intrigued to find out that Spring actually gives a out-of-the-box, what's called a shallow eTag filter. It's just a servlet web filter. Nothing to do. You don't even have to use the rest of Spring to take advantage. But it is shallow in that. Let's see. I'll pull it up real quick. So the shallow eTag filter, this one actually processes the request, gets your view that you're going to send back on the response, and then does a hash on it and stores that. And then on a subsequent request, it'll do the same thing, and if it matches, it'll send back the 304. It will not. Won't pass all of the stuff over the wire. So you're not saving the processing time. I think that's what they would mean by deep tagging. They say, oh, we'll talk about deep tagging later, but I couldn't find any reference to it. But their shallow one, at least if you have a really large response, if you're streaming documents or something like that, you could avoid the wire time. Sounds like really easily. So that's pretty cool. All right. Anything else there? Cool. All right, so now I'm going to jump into some of the team stuff again. Like when you're in a larger team, some of the stuff we've done to make sure we're all in the same direction, all in the same line, following the same standards. And that's with integration tests. And this is what Spring allows you to do because of its pulling all your dependencies out into the application context. So early on, I talked about the add controller annotation and how it extends component and how the it's called stereotypes, how they're very useful. And this is where it gets really super useful. If you can make your own custom one, Spring gives you controller, service, repository, and then just a generic component one. You can make your own. If you have your own, specific layer that you want, make your own that extends the component annotation. So Spring will see it as a Spring bean, and you can also, in integration tests, in interceptors, wherever you need to identify that layer of code, you can. So that's what we'll see here. So what I've done is I've got some integration tests. And I've got I did three test methods. One, test no deprecated endpoints. So we made our own annotation. So I'm a new developer on the team, right? And we have our custom annotation that says deprecated endpoints. If I was just a normal Java developer, if I was going to deprecate something, I would use the deprecated endpoint, and that would be like, why would I use something else? So what this does is, if I try to do that, let's bring up my task controller again. Not in the old project. So I'm going to come in here and not knowing any better, throw that in. Stop that so we don't get interrupted. And I'll run this integration test. And I have a couple failures here. So I obviously did not conform to the to the standard. So I look and it says specifically, oh, I used the wrong deprecation strategy. I have to use deprecated endpoints. So without going to somebody and asking a question, why doesn't this work? What's going on? I've self-learned that I can use a different annotation to do it. Now, if I add that same thing to, if I add deprecated to an endpoint that already has a deprecated endpoint annotation, that is more ideal, because then if you're looking through Java doc, you see that it's deprecated and the endpoint is deprecated. And another extension of that is we have an automatic REST documentation tool. And from this deprecated endpoint annotation, we can visually show that, hey, don't call this annotation. We show it in the documentation, but we, scratch it out or color it red or whatever and make sure people don't call it. So I got another test failing, and this one is request mapping at the type level. So request mapping is a really flexible annotation, and you can put it on an entire class so that that path comes to the entire class. And that was something that we weren't interested in. I'm not saying it's a bad practice necessarily, but we weren't interested in. So we actually created an integration test that made sure that you didn't do that. And because that gets confusing, that's where we're out of kind of our sync with design. So when I ran that, then conveniently, it's in a request mapping controller. I don't know how that happened. As soon as I take that off, go back to JUnit, and we're good to go. So now I know that I've conformed to the team's designs and how everybody wanted to work. And then we'll go over this one in a second. But what I want to highlight in writing tests like these, the reason that I'm giving this talk and we're talking about this in a Spring talk is Spring is what makes this possible. Whether it's the endpoint tests or the request mapping, here I'm getting a list of all the beans that are annotated with controller. So here's where if you had your own custom layer and you wanted to get all the classes that were annotated with that and apply some standard to it, you've got your template right here. It's very, very easy. One line, you got a list of all those beans. A side note that got me for a while, when you do get a list of beans, they're wrapped into Spring proxies. And luckily that Spring gives us the AOP utils, which allows you to get to the actual class name. That messed me up for a while. But then I went to Ryan, and that was all good. All right, cool. Good. Any questions on those? Cool. Next guy, JMX is another place that Spring helps us out. If you're not familiar with JMX, it stands for Java Management Extensions. It's an easy way to get meta information about your application. And I say meta information just because it runs on a different port. So if you start up Tomcat, you're running a web app on 8080, you have to pick a different port for JMX to run it. It has a different JMX protocol to get the information. And I'll show you that here. It's really useful in a very structured environment. We have 4 environments at Thomson, and when you're in the lower ones, developers have more power. When you're in the upper ones, you really want to keep, when you've got 1,000 developers working on a project, you want to keep their hands out of, they're not querying the databases and not fiddling with stuff. So JMX is our solution to that to make sure everybody's doing it right. So JMX is something by itself. You don't need Spring for that. Just to give you a taste of what it's like without Spring before we hop into the Spring implementation, I started looking at creating a bad example of this, and I stopped because I didn't want to waste my time. Oracle's documentation for it here, you create a bean that you want to execute a method on via JMX. And then, so they have an interface and an implementation. And then I'm scrolling down this because it doesn't matter. I'm scrolling quickly. But I have to create an MBean server and get an object name and register my bean. Each time I create a new MBean, that's what the interface into JMX is called, MBean. Each time I create a new one, I need to register it. Oh, and if MBean server already exists, I can only have one. There's a whole bunch of rules around it. And then when you put Spring in there without using their specific JMX stuff, you got to register the beans in a certain way, and there's just a lot of overhead. It gets unruly, and all you're trying to do is access some data about your application. When you come into the Spring JMX convenience annotations, I've still got an interface, and it's my task MBean interface, and all I want to do is retrieve a summary of the tasks. So who has how many and how many total. So I implement that by using a couple annotations. One, I mark it as a component, and that means it's just a Spring bean that gets wired into the application context. Second step, I mark the class as a managed resource, and then I give kind of the path to that class. And we'll see this when I connect to the JMX process here, so don't get worried yet. And the name of that that resource there, and a description. And then when I get down to a method, all I do is I'm just creating a public method that returns a string and marking it as a managed operation with a description so that when you're in the MBean, you know what your execution is actually going to do. And once I do that, then Spring takes care of the rest with one caveat. This is the one thing I could not find a Java configuration for. That does not mean it doesn't exist. That just means I didn't search long enough, probably. And so in here, I added one line, context MBean export, which means it tells Spring when it starts up, if you find any MBeans, make sure they automatically get exposed, or exported is what they call it. If I didn't have this, then I would have to manually do it. And so now anytime I add those managed resource annotations, it'll just automatically put it out there. So I'll make sure I'm running the latest here. So if you haven't connected to a JMX process before, JConsole is a handy way to do it. There's also Visual VM is really good too. That you can save remote servers, and it's a little bit more handy. And that comes with the JDK now. But you just type in JConsole from your command line as long as you got access to the JDK. And it brings this window up, and I know, oh, that's right, I was going to show you. In order to expose JMX in my web application, I need to tell Java to expose that, otherwise it won't be accessible. And how I do that is on my server, I give it a number of properties, those highlighted ones. The JMX remote flag, the remote SSL equals false, I'm not on that. Authentication equals false. You can have username and password to secure your JMX endpoints. We'd certainly do at Thompson. And then the remote port. The port is important, obviously. So when I get to here, I'm actually, even though it's on my local machine, I'm going to connect to it as a remote process. So I did localhost, and then I said 9004, and that's all. Connect. So this is where you get a whole bunch of information. If you haven't checked out JConsole or Visual VM, it's really cool, and that's another whole talk by itself. An overview of heap, threads, classes loaded, and CPU usage, and then more detailed information on each one. A summary so you can see what VM arguments were started your application, your library path, etc. I think it's someplace in here. One thing that Visual VM does, it's like a more standalone application, a little bit larger, and it's got plugins, is it gives you a list of the system properties too, which I found extremely useful. Especially if you have a deploy process that you're not in charge of, you don't necessarily know how the properties get there. You can actually go out to the instance running and check out what system properties are running. So it's kind of cool. All right, so finally we get to our MBeans. Notice I've got com.image.task, and that's what I put right here. And then my type, data summary. So I expand this, I get data summary. Expand that, task summary. It's all making sense, lining up. And then I've got operations, and you can expose just individual attributes as well if you just have a member variable that you want to keep track of and find the, like cache side, if you have a cache running, that's a common one. You might just want to, just that attribute is what you're interested in. So I just have this, this operation. Now you can add method parameters, so I could pass in a string and say, pass in the username and give me all the tasks for this user, or you can do stuff like that. I just kept it simple. And so I just got the task summary. So this called my service that goes and gets all of the tasks and gave me this information back. So I know Sam has 4. The total number is 9, and I have 5. So here's where the possibilities are endless, and you can use your imagination for what kind of information you can do. We use JMX quite a bit at Thompson for various reasons. The code behind this is nothing special either, and it doesn't use, Spring allowed us to do this. I get to auto-wire in my service to retrieve tasks. So that's what makes it just so smooth. Yes. The question was, can you write a standalone client for JMX? Right. Yep, absolutely. If you wanted to write your own application that connected to JMX, that's absolutely possible. I know we've done that in a couple of scenarios when, for example, we may be using and abusing JMX in this way, but if the method input that you're trying to send isn't natively supported by JConsole and JMX, for example, like a file, if you have a lot of data you want to pass to an endpoint, a JMX endpoint, it doesn't by default do that, but it'll take a list. And so, you can write a little console application that rips through the file and turns it into a list and calls it. Stuff like that. Mm-hmm.
So, here, we might have some stuff that needs to be developed. We're hidden. It's not a thing.
No, we wouldn't implement anything in JMX that wasn't production ready. So an example, I guess, would be if, say we have some data in the database, and for various reasons, either corrupt, some users became corrupt, or we have to migrate data from one place to another. This is an example where we would probably use JMX and would, so that we could control the process that started that, fixing that. We would write an implementation of a job that would go and query to find the users that needed fixing, and then do whatever action they needed. So whether, let's say, moving data, it would find the users that needed to move data and then go move their data. And we would probably execute something like that via JMX. Does that make sense?
The process where it's through the string of beans to the interpreter, like the old versions where in the older versions of string you have to actually make the class extended interface and then have the interpreter register that class. It's all internally dealt with, right? With the annotation.
Yep. With the annotations and then the one XML configuration line to export it. Yep. Yeah. Ideally. What we found is theoretically it's a one-time job, but if you have 1 million users, you're not going to do them all at once. And so you're actually running it multiple times just because of the massive data that you have. We absolutely will resort to a query first because it's easy to write an update, do it in the middle of the night, and get it done with. What we find is a lot of it is more complex and involves a lot of business logic. one example would be shards. If you use different buckets for your databases, that's hard to run a query on if it gets complex enough. And so that's where we turn to Java code, business logic, and a JMX endpoint that can be tested in all environments as we move up. And then once we're confident that it's worked in the lower environments, we can run it as many times as we need to catch up and get production up to speed. Does that make sense? Awesome. All right. I've got two last quicker topics that I wanted to show. One is the Bean factory post-processor, and then we don't use Bean post-processors very much, but I don't think that I could mention a Bean factory post-processor without at least explaining the difference between the two. So the Bean factory post-processor allows you to take an action on a Bean definition, which is starkly different than the thing I'll talk about next. When you implement a Bean post-processor, you're implementing the Bean factory post-processor interface and marking it as a component, so it's in the Spring context. Now, there's several applications of this. One of our coolest, newest ones that we're working on, if you're in a distributed web service environment, you might have some pieces that maybe you're using OSGI and you're actually deploying some components together on the same hardware, and then some are remote across the network. I know we had this with our previous web service that we did a while ago. So you want to figure out, okay, do I make a REST call to go get this data, or can I just call it via Java? Obviously, the preferred is Java, especially when you get into a heavy used production environment. And so with this one, you actually you can get a list of the beans that you have available to you, what's been wired into the application context. If you have two implementations, one's a remote and one's a local, you can make an educated decision about which way you should go. Where you'll see this most often is the property sources placeholder configure. This is the, I've been switching back between 3.0 and 3.2 so much that the property, I think it's the property placeholder configure is what it used to be called. But this is just a very convenient way to get properties. So I have a very simple demonstration of this. All right, so we want to get this mystery property. All right, so the endpoint is totally unrealistic, I understand. But what we do is we go, if we dig into the implementation of this endpoint, we find that in the service, it's just returning this attribute. And when we go to the attribute, we see that, oh, this is pulled from a property. Well, Spring by default gives you this property placeholder configure, and it is itself a Bean factory. Bean factory post-processor that swaps out this value with your system property value. And so I've got that registered in my properties. And now if I come to see if I can go out on a working demo, that'd be pretty cool. V1 mystery property, which is no longer a mystery. Here's a get. Here's V1. We'll see if it works. And it says it worked, so it worked. All right. Obviously, this isn't an example of a real application, but what that is your logic to load properties and use them more aptly. You don't have to do system.get property anymore, which is another beast to unit test, right? You have to mock out the environment, try and figure that out. You don't have to do that anymore because now that's all wrapped up in our service as just a attribute, which you likely have a getter or setter for, and it's really easy to mock. So testing is, obviously throughout the theme, is easy testable. We do a lot of unit testing, as much as possible. And we drank the Kool-Aid, I guess you could say. And so this is what all this stuff does. I see a question. Yeah.
I wanted to point out one additional additional advantage here is that if these properties are some environments, they're coming from properties, environments that come from the properties file. With this, you don't have to know different.
Right.
And string just doesn't.
Thanks. And then there's one bit of configuration I did to make this happen. So we'll go to the Spring configuration, the Java configuration file I have. And here's just declaring a bean of type property sources placeholder configure. And then this is one way I did it for simple for demonstration purposes. You'll likely want a more elaborate, more robust property loading scheme, but it does the job. The other thing we do with bean factory post-processors is I spoke briefly about endpoint tests. We have some endpoint tests that hit our database, but when we make calls up to kind of external web services, we don't want to hit those via when we're just running tests. And so we have a factory post-processor that actually swaps out our stub implementations for our real implementations. Just another idea. And then the last thing, the bean post-processor, just for contrast, oh, you know what? Yeah, while I talk about this. This one, the biggest difference is bean post-processors work on the actual bean instances, as opposed to the factory, which is on bean definitions. And so a lot of people use these to wrap the beans in proxies if they need to. I didn't find any examples where we use it very heavily. If you, Ryan, if you recall any, let me know. But if for anything, it's really easy to fat finger it and type this when you're in factory post-processor, so it's good to be aware of. But I did implement one just to demonstrate. And where I think it becomes clear. Okay. I have a very simple, this is going back to the factory post-processor, just to show it running. So all I did here was implement bean factory post-processor, mark it as component, and then I wanted to find out what beans I had in the system. Like I wanted to see, what beans does the Spring just put there by default, and then I want to see my own controllers and services in there. So I just looped through. I got beans for type, and I just threw an object, and then I looped through all of them and just print out the bean name. And now when I do that on startup, we will see a list of all of the beans that I had. So these are the definitions before they're instantiated. Now if you want to do something to an individual bean before or after it's instantiated, you can go to the bean post-processor. I didn't want to litter my console with a whole bunch of outs, so I'll put these back. And now when I have a bean post-processor that, all I did, there's two methods. There's process before initialization and process after initialization. And then when you implement one of these, it gets called after every bean that's instantiated, or before or after. And so here I'm showing that we're processing the post-process before initialization method for this bean, and then immediately the after initialization method for the same bean. And it repeats that for every bean that we just saw. It gives you an idea of when it's called. It's all startup time, what you want to do at startup. Some other interesting ideas I just came to mind. I forgot what one of our teams does on the factory post-processor is if you have a larger cache, say you're filling up a database upon application startup, that's a good time to kick that off. So if there's an large initial cost, so let's say the first web request to your application, that's a good place. Then no clients have to suffer that cost. So that's all I had to demo. There's a few things that I wanted to at least mention that we also use Spring for. One is we have a lot of aspects. For database transactions, we have our own aspects. For security, if in a REST-based world, if the user's not supposed to get to that resource, logging. Here's where it comes into play with if you have a stereotype for your repository layer, you can log every database call if you want. You don't have to. It gives you a lot of flexibility on what layer you want to do that. JDBC, here's a quick table that shows you what Spring does and then what all that you have to do using Spring's JDBC stuff, straight from the Spring website. Yeah. I didn't dive into the security of this because I knew we would run out of time. But it's something maybe we can talk after. And the other really cool one is Handler Exception Resolver. So I mentioned, oh, you know what? I didn't even show. If I was excited about this one too. All right. If you're down in the service and you don't find, I'm looking for a specific task. Oh, that's why, because my demo choked on this one. Otherwise, I would have shown this. If I'm looking for a specific task and I can't find it because it's not in the database, you send back a HTTP 404. All I have to do is throw a task not found exception, and because it's annotated with response status, that status automatically is propagated back. Now, there's probably exceptions in your application that won't have this response status annotation. That's what the Handler Exception Resolver does. It helps you categorize what HTTP response codes and what to do with various exceptions. It's really, really powerful and deserves a lot of time itself to go, which is why I didn't go into detail. And then stuff that we're interested in that I just saw came out. One is Spring MVC Test. We have endpoint tests to test our controllers. Now, with MVC Test, you can test request mapping and all those annotations and all the aspects outside of the web context with a unit test. And that'll cut, like our builds are long largely because of some of the tests we run. And that'll cut them down significantly. We're so excited about that. Embedded database support, just more native, a lot easier to get an SQL database up and running in Spring, that kind of stuff. For us, it's going to be really cool just for locally. If you're remote, everybody's going telecommuting, that kind of stuff. If you're passing a lot of data, setting up a lot of data in your database for your tests, it takes a long time to run those builds. And that's what we're seeing, so we're excited for that. REST template, just easier and more intuitive to consume REST services. Spring Batch, I mentioned it briefly with the JMX stuff. We run a lot of batch jobs if we need to fix data, et cetera. And so this Spring Batch should help us with that too. So, if there's any other questions, we'd be happy to take them. Otherwise, that's all I have for today. Okay.